Hi, I'm Steven Sloboda,
I'm Lauren Wong.
and this is our EECS 373 Design of Microprocessor-Based Systems project. It's the glove-controlled robotic hand. Our project consists of a robotic hand that's controlled by servos, and this is linked to a Smart Fusion FPGA and microcontroller. This whole system is controlled by a glove that the user wears. The user's motions are detected by this glove and sent to the microcontroller. This analog joystick also controls the robotic hand, allowing individual control of the fingers. This LCD shows menu options, and the menu options can be cycled through with push-button switches. Other uses for this technology would be controlling medical instruments or just robotics in general. You could translate this motion to larger scale robots that would be larger than the human hand, or you could scale it down to small medical instruments that could be used for surgery that are much smaller than a human hand.
Our user interface consists of three options. We have the glove for glove control, we have pre-programmed animations, and we also have an analog joystick. The LCD menu here shows different options that we can choose. The LCD is controlled by the push-button switches, which are located on the Smart Fusion FPGA. Here, we can cycle through the different options, and currently it's showing different animations which the robotic hand can perform. And here we are at the analog joystick. This enables analog joystick mode. The analog joystick outputs varying voltage corresponding to the position of the button. So if you move the joystick up, it will output a bigger voltage and a lower voltage when it's down. We can then use these voltages to transmit our positions to the servo. We could also use glove control, where we enable control using our glove. There's flex sensors mounted on the glove, one on each finger, which can be used to detect the bend. The flex sensors change resistance depending on how much they're bent, and we can use these resistances and apply it to a voltage divider, which tells us the output voltage and use it to control our servos. We also have a gyroscope, which we use to detect wrist rotation. These output a 16-bit 2's complement number that detects the angular rotation rate.
The heart of our system is the Smart Fusion microcontroller and FPGA. The microcontroller and the FPGA communicate via the APB light. A Verilog timer module triggers interrupts at periodically to determine our sensor pull rate. This flex sensor voltages are converted to digital numbers by onboard analog to digital converters. The flex sensor values are put into a moving average to smooth out noise. Gyroscope input is read through an SPI interface and multiplied by a sensitivity constant that converts the number into degrees per second. We use numerical integration to convert this rotation rate into the angle that the gyroscope is pointing at. We can calibrate the gyroscope to have a specified zero position. The analog joystick values go through an analog to digital converter that has an I2C interface. The microcontroller reads from this chip with an I2C read. Again, these values are put through a moving average to smooth out the noise. Software translates these voltages into PWM values. These values are sent to the Verilog modules for PWM, and that is then sent to the servos to determine their position. Pre-programmed motions are able to be executed by writing in software by writing certain PWM values to the servos. This allows us to move our hand in any way that we want to without input coming from the glove or joystick. The LCD is communicated with via UART.
Our robotic hand is 3D printed. The 3D printed STL files come from an open source project known as InMove. The hand is printed in ABS plastic. The hand is controlled by wires on the servos. As you can see, the servo rotates, which extends one of the strings, and then as it rotates the other way, it contracts the other string to contract the finger. For wrist rotation, we send a PWM value to the servo mounted here, which controls the rotation, and we send different values to the servo to distinguish the angle to which it is set at. Overall, we managed to control the robotic hand pretty well using our glove. Most of the issues we faced in our project were mechanical. Most of the instances happened when like a finger got stuck due to the wires mounted here. This could be solved if we controlled the robotic hand using micro servos and gears instead of wires. Another issue with our project was the amount of wires which we had. We came up with ideas of using XPs too late, so we weren't able to implement it in our project. But looking back on it, using XP would have made our project much neater and less cluttered. And our gyroscope also had an issue with its wiring, which an XP could have also solved.
Just beat it. You have to show them.